Okay, so I hope you can see the slides. As with yesterday, please feel free to interrupt me midway if you have any questions. Otherwise, I can also take questions towards the end as well. Okay, again, before I start, today's slide was also, so most of the material that I'm presenting for this particular session is prepared by the team in Universität Hamburg. So basically Matthias Max, Marx, Florian Wilkens, and Nuref Sansadbas. So I'm helping to present them. And of course, I made some modification in some of the slides that I'm going to present. Okay. Basically, this is our agenda for the first 1 hour. We have roughly about 50 minutes to go. So we are going to talk about network monitoring. What is network monitoring, how it's done, what is intrusion detection system, how it's done, and then I'm going to just summarize it. All right, so the bigger picture is the PDRF process, which starts with prevention, detection, reaction, and recovery. So this is a common flow, and this is what we call the big picture. And the prevention is the concept of having secure system designs and classic IT security. And this starts with firewall, if you want to talk about prevention. And if you want to talk about detection, we have something called intrusion detection systems and also honeypots. And for reaction, as in upon detecting an intrusion or something, how do you react upon it? We use firewalls. And this would be the different components that we are going to actually cover today. Let's start with network monitoring. So again, based on the input that you all provided earlier on the website, seems like most of you already know the basics. So I'm going to touch slightly more on let's call it theoretical descriptions of what is what and so on. But if you need further clarification or if something is not clear, just stop me. Okay, so when we are doing network monitoring, what do we want to know? So we want to know who accessed what, when, and where, including how. So basically, if someone accessed our web server, we want to know who accessed it, when he accessed it, how. So how here would be in the form of which browser did he use, which IP did he contacted this web server from, and so on. So additionally, we want to know whose and which resource that was accessed or used, including performance, quality, and other questions. So these are the reasons why we want to do network monitoring. And why do we want to know this? Is because by doing network monitoring, we will then be able to do intrusion detection. If you do not monitor, you won't be able to do detection. And a lot of IDS systems, as we will explain later, are actually a combination of network monitoring tool plus this IDS system. So it's not just IDS works by itself, it's actually having an underlying component of network monitoring. So yes, so we could also carry out fault management. And for number two, we are able to do analysis. And this analysis is in the form of system and service monitoring for reachability, availability, and so on. Being able to plan whether we should allocate more resources. For example, if you have noticed that some of the internet-facing services that you are hosting in your organization requires more resource. Let it be bandwidth resource, or probably the CPU that you are actually deploying it is not able to withstand the amount of traffic that is coming in and stuff like that. You can then plan, okay, should I upgrade the machine? Should I actually upgrade the pipe that is leading to the machine, and things like that. And of course, this will also help to perform optimization of your services, as well as to provide statistics for accounting and metering. So if you're an ISP and you decide to actually provide some kind of metering, so let's take a simpler example. So you have a cloud service provider. This cloud service provider says that, okay, for the month of November 2020, I'm offering you 20 gigabytes of transaction, network traffic, and anything beyond that you will have to pay by every gigabyte of traffic, let's say. So you need to perform this kind of monitoring or metering to provide them utilization rate, as well as how much they have utilized right now from the beginning of November and so on. So then you can build the customers according to your usage. Let me just turn on my chat because I might otherwise lose. Okay. All right. So the overview, the goal is to collect useful information from various parts of the network. And the main purpose is so that the network can be managed and controlled using this information. And the sequence of activity towards that is that you first have to configure device to generate flows or basically to generate flows that are happening or flow accounting based on your network. And then you want to export the flows to a device from the device to a collector. And once the collector receives the flow, it will write them to the disk, and on a later stage, or immediately, we can actually analyze the flows and do something about it. We will cover them in a short while. So how does this flow collectors look like? You can think about managed switch. So if you have a layer 3 managed switch or even a router device, if it has the capability of port mirroring, so you can actually mirror all the traffic that is going through your device to a particular port. So what happens is that you will be able to have a copy of all packets that is either coming in or going out, or however that you have specified this port mirroring feature. Now, this is a very resource intensive process, but it would be one of the most, necessary thing to do if you want to do network monitoring. You're not introducing anything in between, so it's not active, it's purely passive, but it's resource intensive depending on your organization, how much traffic is being generated by your organization and so on. And so yeah, so from a network device, let's say a router, you need to have some kind of a device support. But if you have the support for port mirroring, as I mentioned, there will be some impact on the performance to a certain extent. Yeah, but usually it's fine. And a flow, right? So basically, if you're looking through your network switch and then looking through whatever that's coming into your network, you would see them in the form of packets. So you're doing packet capture, but flow is something else. Flow is some abstraction of that. So you don't actually look at everything, you just look at certain things, and we will see what are the examples of these certain things. So flow is defined as a set of packets having common properties such as common packet header fields. And there are quite a number of protocols that are that can be used in order to generate flows. So you have net flows, you have net stream, quite a number. So you can actually refer to the slides if you're interested. And if you have a NetFlow enabled device, this is how a flow would be looking like. So you have a source IP, source port, destination IP, destination port, what type of protocol that is being used on layer 3, TOS, and as well as which interface that you actually saw this flow coming and going. So NetFlow can be used for several applications. For example, to answer questions regarding IP traffic, who did what, where he did it, when he did it, and how he did it. So for example, you can answer the question of which user or department has been uploading or downloading the most during working hours, for example, or on weekends and so on. So if you're from the university, it helps to actually do such analysis to identify your next course of action. For example, in our university, quite some years ago, YouTube was actually not allowed from the network administrator's perspective. So they would have blocked all YouTube traffic from the university because they claimed that we don't have this, we don't have enough bandwidth to support during office hours, and after office hours it's allowed. But eventually they did a better study, and then they realized that yeah, YouTube is something that is quite critical even for the academicians, and then they have decided that okay, fine, we have enough resource right now, we will uplift our previous decision and so on. So you can make such decisions for your network based on your user pattern, let's call it like that. So you can also find out what are the most commonly used protocols in my network. And this can also be used to identify anomalies and attacks. And the nice thing about flows is that you can have more fine-grained visualization. So you can have presentation of collected and processed data in a user-friendly format. We will look into some examples in a short while. So let's imagine that a DDoS attack is taking place on a router. Basically, you would be able to see such behavior where you have the same interface, the source interface, same destination interface, same destination, of course, and the packet size and bytes per packet will be the same and so on. And such information allows you to then make a decision on, if I see such a pattern, what would it mean? For example, you can have a threshold that says, if I see 500 packets within a minute that has at least blah, blah, blah size of packets, I can then conclude that this is, let's say, a DDoS traffic and so on. So there are ways to do this, but good enough for you to know that from the monitoring itself, there's a lot of information that you can tap on. So if you're a researcher, as are some of them researchers, you can actually use netflows to actually extract certain features that you would like to work with. If you want to characterize something, if you want to introduce an anomaly detection mechanism, if you're working on machine learning algorithms, there's a lot of things that you can actually do with netflows itself. And the real cool thing about netflows is that you do not need to do deep packet inspection, which means you do not have to look at the payload at all. That makes the whole collection process being faster, as well as safer. So network administrators will not be able to, will not feel, how to say, reluctant to share you some of this flow data compared to you asking them to give the packet capture itself, which means with the payload. That's highly unlikely. Not that I've been successful before, but with netflows, I've been more successful contacting administrators, asking for assistance to collaborate and get some data and so on. Okay, I will probably skip some of these examples on how netflows can be customized. The commands can be customized to show certain things, because I think there's a lot of things that we want to cover today. Yeah, so what are the top netflow analyzers and collectors? So in terms of the features of these analyzers, we are able to receive flow records from the exporters and analyze this record to produce sensible information. And obviously to present results in a more user-friendly way. We are just human anyway, and we should be able to see everything in a single glance. There are quite a number of examples that is available for the flow collectors, but we will look into some of them. So this tool is called scrutinizer. So basically from the flow information, it is able to generate the network topology. For example, here on the top left, there's this office network image. It's actually showing the reconstructed network topology of how this analyzer is actually perceiving your network based on the traffic that came in, the TTL counts, and whatever not. This is how it's actually having it. And then if you look at the bottom, you have this report filter that shows the pattern based on time, 1 minute interval. You can also see the top applications. For example, what portion of nodes in your network were using HTTP traffic, or were using certain services like emails and so on. So you can quickly have a look at how's the network being, or how is the users utilizing the internet in your network and so on. And it's the same. In fact, certain tools have more friendlier things. Certain tools have more complex things. So as a network administrator, or as an, let's call it the security guy, for example, you need to know which tool that you want. You might want to use more than one. You might just use one. So it's a matter of you getting to know what tools out there and then figure out which thing actually works best for you. So we have Manage Engine. We also have SolarWinds Traffic Analyzer. And yeah, so now that we have performed monitoring, what comes after that, right? So monitoring alone, it's not enough. So yes, I know traffic coming in, of course, I can visualize it, but what else can I do from the perspective of a security administrator, let's call it. Next is obviously I would like to work on the detection component, right? So I'm now able to look through the features that I want to look at. Now I want to actually detect intrusion, as well as to deploy honeypots. We will cover the intrusion detection system first, and then cover what is honeypots. And finally, firewalls. Now, for the firewalls and intrusion detection system, so the implementation of firewalls itself requires two components. Firewalls, under the reaction category, the firewalls require two features, which is to prevent as well as to detect. And that's where intrusion prevention system, or IPS, comes into the picture. Let's look at IDS. The overall goal is to conduct supervision of computer systems and communication infrastructures to detect intrusion and misuse. So why do we want to detect attackers? So a full protection is usually not possible. You can try as much as you want, but it's just a matter of time before something new comes up, right? So security measures are too expensive or having too low flexibility, because it's not possible for you to build every functionality in your network, especially for a small organization. So unpatched systems for compliance reasons. So if you're from the medical field, there are situations where you cannot patch the medical systems. So imagine a particular device that's working on a particular operating system. You cannot patch them because it's required that you have to use it as it is, because only then the guarantees provided by the company that have actually sold you the product, or it's a government policies and so on. But when you have such a requirement, how else can you, let's call it, put a wall around it so that you know that nothing comes in or nothing goes out? So how do you do that? So this is why we need to detect attackers. So what can we attain from intrusion detection? Number one, we can actually detect attacks or attackers. And number two, we can detect system misuse, including misuse of legitimate users. So for example, certain users are not allowed to access certain regions, or someone from the sales department is not supposed to actually access the HR records, for example. So how can we actually detect this? Is all included under intrusion detection system. So it's all, the definition of anomalies is what we will use to distinguish between attackers or this kind of misusers. So IDS is just a fraction of this detection step. There's a lot of things there. And using detection system only makes sense if there are consequences. And possible goals for this is that we have a limitation of damage if an automated response mechanism exists. So what else can we do? We can actually gain experience to recover from an attack and improve preventive measures. So if you are able to detect, and even if you are not able to prevent it immediately, you can then take action of, okay, so this is where I actually messed up the previous time. I will now do this. I will improve my organization's policy so that this will not happen in the near future, kind of a thing, right? And deterrence of other potential attackers. But this is only if and only if the police is able to arrest them. So this is unlikely if you ask me, but the first two, yes, it makes sense. By the way, is there any questions so far?
Again, everyone, if you have questions, you can type on the chat box or open your mic. All right.
Okay, so yeah, so if there is any question, please let me know, because I'm on the slides on full screen right now.
Yes.
Okay, all right,
Oh,
thank you.
someone has a question. How
Oh,
do we prevent false positives from Nestor Lim?
sorry. Wait.
He's asking how to prevent false positives.
Yeah, okay, we will cover that in a short while. If I don't cover this, just remind me towards the end again. Okay. Okay. Then, yeah, so the operation of intrusion detection systems. So we have a few components. So we have this monitoring component that we have already spoke about, and then this monitoring component will actually produce logging that can then be used with IDS systems to perform detection and reaction. So, sorry. Okay, so the monitoring component records whatever that we have seen in terms of relevant events of a system or a network. And then the detection component will perform automatic analysis of what we have actually recorded. So it will make sense of what we recorded. And based on that, we will then escalate, report, alerts if necessary. And finally, if you have the capability to perform automatic reaction, we'll also initiate countermeasures. So the audit data, we need to record security related events, as I mentioned. So from a computer systems perspective, it's so a single host. It's in terms of which files are being opened, which programs are being executed, is there any access violation that is being performed, if there's any password verification that has failed. So these are examples of how the audit data from a computer system will look like. From a network's perspective, we are more concerned about the connection establishment and the release, what kind of handshake, did the handshake fail, and stuff like that, as well as packet transfer for a specific system or ports. So basically everything from the network perspective is of interest. And of course, app-specific events. These are events that are application-specific and indicate security relevant activities. Now, input for the intrusion detection mechanisms requires integrity protection. So when we say about integrity protection, it means that we need to know that everything is self-contained and one component do not influence the other component. So this is what we mean by integrity protection. Now we are going to the question. I hope we are going to the question of how do we reduce our false negatives or false positives, sorry. So we need to first understand the confusion matrix for those who are not aware. So confusion matrix looks like this. So you have the detection on the y-axis and you have the event nature on the x-axis. So the ideal IDS systems requirement would be to have high accuracy, which means low false positives and low false negatives. This is what we want to achieve. But that doesn't mean that we will have a system without any false positive and without any false negative. That's impossible, but we can work towards improving that. How? I hope we are able to cover the points today. So true positives here are successful detection of attacks. So if there was an attack, we were able to detect that successfully. False negatives is attacks that we failed to detect for whatever reason. True negatives were harmless events that were successfully labeled as normal, which means it was not harmful. We did not classify it as harmful or an alert. And sorry, earlier was false negative. False negatives were attacks that were not detected. So this bottom left is false negative. I think I mentioned false positive in my audio track. So false negatives were incidences, so there were events that were malicious or let's say anomalous, but the system was not able to detect them. Okay. Now, false positive is actually false alarm, which corresponds to an anomalous event that is inoffensive or not offensive at all. So it was a normal event, but our system classified it as anomalous. So that's what I think the biggest challenge of network administrators, to reduce these false positives. Okay. Requirements of IDSs. Basically, we need it to be easy to integrate into existing system or networks. It has to be easily configurable and maintained by the administrators. And it should be autonomous and be fault tolerant in its daily operation. And of course, it should require low resources. Otherwise, we have to dedicate a big chunk of resource just for this. And also self-protection, so that the IDS itself cannot be deactivated by a deliberate attack. For example, you shouldn't be able to be affected by an attack. So if the attacker knows that, okay, if I perform this particular attack, the IDS will be disabled, and then I can do the real attack so that no one can actually notice that I'm performing this attack. So these are requirements of an IDS. The taxonomy of IDS itself, you can actually split it into two different contexts. You have the scope, we have the architecture, and we have the different detection mechanism. We will go into one by one in a brief manner. So for scope, we have three different types of scopes. We have host-based, network-based, and hybrid. Obviously, host-based is one that you install on your own device. And host, it performs analysis of system events. What's being accessed by whom, how, what is the pattern it's being accessed, and so on. Network-based allows the analysis of communication data in terms of IP packets, and hybrid combines both. So you also look at network, you also look at the host data and make decision based on it. Okay, so for host-based systems, it works on information that is available on a system. For example, you have OS logs, application logs, and timestamps. And these can easily detect attacks by insiders, like modification of files, illegal access to files, installation of Trojans and rootkits. For example, if you have a company policy that says none of the Office documents should be transferred or copied into an external storage device, this can be used to monitor this behavior. So if you are actually looking at all the traffic, or sorry, all the activity that is taking place on an Office notebook, so to say, you can actually keep track of when someone is actually copying certain file into a pen drive. So that's against the policy of the company, and that can be detected, for example, right? So if someone is actively installing a Trojan or rootkit onto the device, it can also be detected. I mean, okay, not actively, but if someone is accidentally installing or something as well, it can be detected. Now, the problem of a host-based system is that you have to install on every system. So if you have 20 employees, you have to install on 20 devices, which is still okay. But if you have 2,000, if you have 20,000 employees, it's not scalable. And it will produce a lot of information, the monitoring itself. And often you don't have any real-time analysis, but predefined time intervals. You will still have to aggregate the data that you have seen, send it, and then to process it will take some time. And as I mentioned, it's hard to manage a large number of systems. One example of a host-based monitor is this OS query. And OS query performs high-performance database view on OS events. So basically, it uses SQL tables representing abstract concept. It's fast and battle tested, which means it's tested quite well on the systems. So you can actually look at a lot of data on the system. For example, the running processes, who's logged in as users, when does password changes, what are the USB device that's connected, what are the firewall exceptions, what are the ports being listened, which means what applications are listening on what port, sockets, and so on. So all this kind of information you can actually get using OS query. And it's very, very high performance and uses only low footprint in distributed host monitoring. So it queries the system in an abstract way such that it runs everywhere. So it's independent of the OS, software, or hardware configuration. So you have a daemon, so host monitoring daemon, that allows to schedule queries to be executed across entire infrastructure. So you can say that every half an hour, do this query on all the devices that you have in your network. It takes care of the aggregating query results over time and generates log which indicate state changes of the infrastructure. So yesterday I had only 2 users in this device, user accounts, and today I have 3rd user account. So that could be then considered to make certain decisions in your network monitoring. And OS query is also a cross-platform operating system instrumentation framework for intrusion detection, infra reliability, or compliance monitoring. Now, the point to note is that OS query itself only performs monitoring. It does not have intrusion detection capabilities on its own, but you can build on top of it. So if someone is actually working on a research project that, okay, for the researchers, if you're working on a research project, you're trying to figure out or if you're trying to embrace these IDS capabilities and so on, you might want to actually consider this. This is a very great tool, and it's really, really performance savvy, I would say. Okay, so in terms of the taxonomy, so network IDS. So previously we spoke about host IDS. Network IDS works on information provided by the network, mainly packets sniffed from the network layer, right? So existing systems use a combination of signature-based detection methods, protocol decoding, and statistical anomaly analysis. And this can detect attacks such as denial of service attack with buffer overflow, invalid packets, attacks on an application layer, DDoS attacks, and so on. So quite a number of things you can already do with network IDS. And I believe that almost, okay, all networks should have at least IDS systems. It just depends how many do you have. You might have one in a small group and as well as one in your entire organization, for example. But if you don't have one, probably it's high time for you to actually invest time in setting up one. You have a lot of open source tools for that. Okay, so you often use it on network hubs to monitor a segment of your network. Okay, so imagine that this is your network topology, and this is your demilitarized zone, and this is your LAN, and this is your internet, right? So here in your DMZ region, you can actually configure your switch to forward all data that passing through it to a mirrored port, as I mentioned. You can also deploy it at your border gateway router itself, or sorry, your gateway router. When you deploy it there, then it will probe for all incoming traffic. Here you will have high load, high rate of false alarms, as well as you are able to measure any type of attack attempts from the outside. If you deploy it within your DMZ zone, you're looking for all traffic to and from the systems in DMZ. So you already have a reduced amount of data that you will see compared to the first example. And but you can only detect attacks on this device, which means devices on DMZ itself. So nothing else is actually covered. But sometimes you can actually see compromised LAN devices because you know the IP of your LAN devices. And of course, you can also deploy one, as I said, in your group. Now, this will actually monitor only LAN traffic, and this would allow you to detect inside attacks. So if you have one device that is compromised, and if this device is trying to compromise other devices, this can be detected. Yesterday, I gave the example of nowadays everyone is actually working in home with their own laptops and so on because of Corona and so on. The moment that you're connected on a VPN, or the moment that you actually go back into your office with your infected device, if it is, it may try to actually propagate itself into the network. And having an IDS system in your LAN itself will be able to inform the network administrators that, okay, this particular IP is trying to perform a port scan, for example, on all the nodes in the network and so on. So these are the things that can be done. So you need to know where you should actually deploy your IDS systems. And of course, if you have these capabilities of a central IDS, you can actually feed all this data that is being seen by different components or different segments of your network into a central IDS system or SIEM system, security information and event management system. Now, if you talk about IDS architecture, why did this come first? Okay, so you have a centralized architecture, and the centralized architecture is the example that I just said. You have IDS sensors that are deployed in different regions or different segments of your network. They all feed their alerts into the centralized analysis unit, and this unit will inform the overall administrator of the organization what is happening. Hierarchical means that you have several of these analysis unit, and it will be aggregated at different segments. You can consider a large-scale organization who has multiple branches to utilize a hierarchical approach. So you have every branch may have its own analysis unit, and the HQ probably have this analysis unit that aggregates all the different branches information and so on. And of course, the more advanced version of it has this IDS architecture, which allows all these sensors to, or all these IDS systems to communicate among themselves, to share alerts so that everyone learns about what's happening around their network. So we won't go into details about how this aggregation and so on works. It's good enough for you to know that this exists. So depending on the style of your organization, you can decide on which kind of architecture you want to adopt. Okay. I have 15 minutes, 30 slides, kind of impossible. I will try to speed up on certain parts that I think it's not very necessary. So in terms of detection mechanisms itself, you have three different types. You have signature-based. This is the most common way. The most common IDS detection mechanism. It knows what is malicious. Policy-based knows what is allowed. So knows what is malicious means that someone have already defined, okay, this is a malicious behavior. This is a buffer overflow attack. So this is what this signature-based detection mechanism will do. Policy-based will only say, only this is allowed in the network. Anything else is malicious. And as well as anomaly-based is an approach of telling this is the normal behavior in our network. Anything that deviates from this, no matter how you want to define the deviation, that is not normal. And when it's not normal, an alert will be raised. So this is a very simple example of how IDS can be classified in terms of detection mechanisms. Yeah, I think I won't go through each of it because it's enough to say that the signature base is something that you have to feed in terms of telling it this is how you see it. So you have some kind of update that tells this is how you detect attack 1 or attack A. So every time attack A comes after that, you will be able to detect. But if attack B happens and your system doesn't know about attack B, you will not be able to detect them at all. Then you will have a false negative in your system. So that's pretty much this slide. And so the drawback of a signature-based detection mechanism is that it requires prior knowledge of potential attacks, and you need to continuously perform signature database update. Otherwise, you will have false negatives if you don't have it updated. One example would be Snort. Snort is a good signature-based detection mechanism. So very simple rule on how you can actually set up to detect and so on. But I will not go into details in this talk because we only have 1 hour to cover them. In terms of policy-based detection, the basic idea is to specify upfront what is allowed in a network and what is forbidden. Anything that is not within the category of allowed is considered a violation, and hence an alert will be created. The drawback of this is that you can only detect what you configured, whatever that deviates from what you configured. But in order to do this, you need to be an expert. So if you're an expert who knows exactly that in this system, only this will happen or only this will be allowed to happen, then a policy-based detection mechanism is good for you. Zeek, or previously called as BRO, is a good example of a policy-based detection mechanism. So it is able to perform real-time analysis, and it focuses more on application level semantics, policy-based detection in protocols, and tracking information or the progress, evolution of information over time. And if you couple Zeek with the reaction components, you can have intrusion prevention systems, as Zeek can act as a dynamic and intelligent firewall. So just to summarize how Zeek work, or BRO, no matter how, now it's called Zeek, used to be called BRO. So if you know about BRO IDS, it's the same thing. So you tap onto the network, you have packet capture, and this is Zeek. Zeek allows packet processing using multiple programming language and standard libraries. And on top of that, you can build your application. You can build your IDS system. You can have your traffic measurement and a lot of things that you can actually do. Okay, this is how Zeek can be used to understand your network. If you run this code, this command, you'll be able to see how much of the different file types that are being fetched in your system, in your network. You can actually look at top softwares that are being used in your network and so on. Moving forward, for anomaly-based detection mechanisms, the basic idea is to detect behavior that differs significantly from normal use. For that, you need to know what is normal, right? So users have certain habits in their system usage. So duration of usage, login times, amount of file system usage, and so on. A very good example is when if you have used TeamViewer, if you have used Google accounts on a location that is not Philippines. So if you are originally from Philippines, you have registered the account in Philippines. If for, let's say, next week you decided to travel to Malaysia and you try to log in from Malaysia, you immediately get a notification from Google or TeamViewer stating that you have signed in a location never seen before for this account. So they have some kind of an anomaly detection that triggers this to actually indicate this is not normal. This person always logs in from Philippines, but today is logging in from Malaysia. Could be two reasons. One, you could have traveled and then you access and hence you see this, for which you will say, yes, allow, I'm the person. But it could be the case that your credentials have been stolen and someone from Malaysia is trying to access your account. And thus this is telling you, the original owner, that this behavior has been observed. If it is not you, I will block this access. So that's the concept of anomaly, basically. You need to know what is normal and what is not normal. Yeah, so this is what I mentioned. So in an IDS context, most approaches requires labeled data, and this is something that is hard to obtain. Labeled data means you have a PCAP, or if you have a netflow table or database that's already say, okay, if you see this flow, if you see these characteristics, this is normal. So this kind of label data requires manual tagging. So someone has to manually look into the data set and tag it by themselves. This is hard to obtain and may not represent your network. That's the problem. But if you are able to apply this, this has a very good advantage whereby an attack scenario does not need to be defined upfront. So you just need to know this is normal. Anything else, you can immediately say that, okay, this is malicious or this is anomalous. And immediately you can then figure out what is this anomalous and stuff like that, which also means you can detect a new trend of attacks that are happening in your network. Okay, I will skip this. So as I mentioned, the challenges of an anomaly-based detection is to define what is normal. So it's you need to include every possibilities of a normal behavior, but this is quite impossible, or it's quite difficult because the boundaries between normal and anomalous behavior is not very precise. So just because I'm always drinking coffee at 9 o'clock in the morning doesn't mean that I can't actually drink tea in the morning, for example, right? So something like this. And yeah, so anomalous observation that lies close to the boundaries can actually be normal or abnormal. So it's really, really difficult to actually say what is what without knowing them upfront. So it's a difficult thing. And adaptation of the attacker. So dynamic behavior of anomalous behaviors itself. So attackers often adapt themselves to make anomalous observation appear normal. So if you slowly adapt your challenge, so instead of sending a big bulk DDoS traffic, if you slowly send one packet and then increase your normality, and this is even more to be, it's even more difficult to be detected. Because if you're able to figure out what is this boundary that's being set by the IDS system or the anomalous system, you can then play around so that you never trigger this boundary. So it's a bit difficult for these kind of advanced attackers. So as I mentioned, normal behavior is not static and it evolves over time, and you need to keep updating. Otherwise, you will have a lot of false positives as well. So this may answer the question of the one who asked the question about false positives, because I need to know what IDS system are you talking about? Are you talking about the signature-based system? Are you talking about anomaly-based systems? But I'll take the questions after I finish this session. Okay, I'll skip this. This is anomaly. So those who are interested on anomaly-based detection mechanisms can look further into the details on this on this slide. Okay, because yeah, okay. So let's go here first. Problems of IDS in terms of audit data. There's a lot of data that we will have in terms of what we monitor, right? So significant storage capacities are required. You need to store them. You need to also automatically process them. Now, if the location of the audit data is stored on a log server, the data must be transferred to this server to process. And if stored on a system to be supervised, the log uses significant amount of resources on the system. So you might want to actually use a different system to store compared to the system that you're actually monitoring. And if a system gets compromised, audit data stored on it might get compromised either way. So it's better for you to actually separate it so that your data is actually segmented away so that it won't, okay, it has lesser probability to be infected. But if your overall security mechanism in place is not strong, might not do any good at all, right? And expressiveness of audit data. So we need to know which information is relevant, and audits often contain a rather low percentage of useful information. So pretty much we'll have a lot of information, but what is useful is considered rather low. Okay. Yeah, the privacy aspect of IDS is also interesting for you to know. Depending on which part of the world, or depending on the policies of the organizations that you're working with, this might be, this most likely will be a concern. For example, you can identify users based on their audit data, basically, because you can identify elements such as user IDs, employee IDs in this case. You can indirectly or partially identify elements in terms of names of directory they're trying to access in your Samba server, for example, or your file server. This would have file names, projects that they're associated with. It might even tell you things like, okay, this HR person is actually managing this department and probably this subset of employees and things like that. This can all be visible in the data that you collect. And so the IDS audits may violate the privacy of users. So collected information might be abused if you do not secure them properly. So right now we're talking about the possibility of network administrators that might actually exploit it, number one, or if you did not store this audit information properly, someone could actually access this data and then extract it out, like data leak and so on. So there is a possibility of performing pseudonymous audit, which is to log activities with user pseudonyms and ensure that they can only be mapped to user IDs upon incident detection. So if there is no incident detection, you will not be able to know who is user SK5123, for example, right? Okay. So IDS has limited efficiency in terms of analysis because most IDS systems use a centralized approach. So everyone sends data to a single central evaluation unit. So you don't have any partial evaluation in agents. They just collect and send. And this produces performance bottleneck. And the efficiency is insufficient, especially concerning sophisticated attacks and attack variants with parallel action. So if you see so you will only see if the attacks are actually being done on an individual node. So if they are targeting one particular node, it's easier to see. But if the attacks actually distributed, targeted in a very complex, sophisticated manner, this is not going to be easy to be detected. And high number of false positives. Now coming back to the same question, some research publications out there have reported up to 10,000 false positives that you see a month. And the potential countermeasure here is that you can perform alert correlation to actually reduce that. So you instead of just considering a single alert, you need to correlate a few alerts and see if it makes sense to actually raise the alert. Further problems. Yeah, okay. So I think we still need IDS, but the problems that we have is that you have to be careful about protection against insider attacks. You need to be careful about where you store your audit data. And high number of false positive I've mentioned. You need to do alert correlation. For example, the hierarchical approach of the architecture itself. You can have cooperation among multiple IDS so that you can see if this is a normal behavior that is happening on different network or not. And as I mentioned, distributed attacks may produce alerts that belong to the same attack. For example, distributed port scan, worm spreading, and DDoS can actually be of the same attack, but then you will actually see it as different alerts in your network. Phew. Okay. So summary on IDS systems. We spoke about classification of IDS. We spoke about host-based versus network-based. We briefly spoke about signature versus policy versus anomaly-based IDS systems. We spoke about passive monitoring, and we haven't spoke about honeypots yet. We will cover next. And collaborative IDS systems, we do not cover, but we briefly mentioned about the different architectures that are existing. And for evasion detections, there are several attacks that are targeted to evade IDS systems. I mentioned about how you know the boundaries of the anomaly system, and you try not to actually hit the boundary and stay within the range that is not going to be considered as anomalous and so on. Okay, now going back to the big picture again, the other aspect that we haven't covered would be honeypots, which is necessary for us to understand the next lecture as well. So honeypots is defined, the definition of a honeypot is a security resource that the whole value of this resource lies on the ability of it to portray itself to be probed and attacked and compromised. So this is one device that we want to set up in our network so that someone actually attacks our system. And we want to get compromised, and this is not a standalone security mechanism. So how does it look like? So in your network, you will have a honeypot that is disguised as another file server. Oh, sorry, another server. Could be any kind of server. But from a network perspective, this particular device looks like it's vulnerable. So if you try to actually connect to the SSH service, Samba Telnet service, every one of these services will be available. So if you scan, you will see a lot of ports that are opened, and then there are tools to identify what version of service they're running, and we will automatically portray that we are using one of the known vulnerable service. But essentially, it's not running that service, it's just emulating that service, so that if there is a malware or an attacker that is trying to propagate, they will see this device as a perfect candidate to be targeted. And then when they contact us, or when they so-called exploit us by, let's say, brute forcing username, passwords, and so on, we will then emulate behavior of, you successfully entered the system, and then we will give them minimal features of showing as though that this is a real system. So it's all emulated, but after some, so in the process of a malware entering or an attacker entering the system and then reacting, we are actually keeping log of what's happening. So once a malware comes in, what file is it fetching from the internet? What does it do with this file and so on? So this is a tool for you to understand how the malware works. And based on that, you will then generate a report, or you can decide what to do next with the malware that has been downloaded. So why do we use honeypots? First of all, it's really fun. And good thing is that you don't have any false positive. Why? Because this server does, okay, let's assume that you have deployed in your network with an IP address, but as I told you, this has no other purpose except to allow attackers to attack you, which means normal users would not know the IP of this machine at all. They will never communicate to this device. If someone is communicating to this device, it is not a false positive anymore. It's definitely a true positive. Someone is actually trying to, how do I say, attack the system or access the system for a certain reason. But of course, if that someone is you as the network administrator, maybe you have additional tools that are scanning through your system, you know that this is yourself. But so therefore, you know which is false positive. This is not false positive because you know you did it. So everything else is definitely valid malware or malicious activities. And as I mentioned, you can then take the binary that has been downloaded onto the system and perform malware analysis or reverse engineering on the system. And this would also serve itself as a warning system for new threats. So if you're working with an anomaly based detection mechanism, signature based detection mechanism, if if you see that your honeypot was compromised, but your IDS system did not trigger a detection, you know that, aha, okay, something new is happening in my network. I am not able to detect this attack. Why? And then you can actually figure out, update, or upgrade your systems. The advantage of honeypots is that you have smaller data sets, it's highly flexible, no false positive, and there is a high possibility to catch false negatives. And usually it's low overhead. So it's just emulating. So you have two types of honeypot. You have low interaction honeypot, everything is emulated, and you also have high interaction honeypot. So you can have a bare metal machine, so a physical machine or a server that you dedicate for this. So it will have more functionality, so you can actually learn more about the malware. The drawback is that you have limited visibility. You don't see everything. And you are introducing an additional attack surface. For example, if you have this vulnerability in the honeypot system itself, then of course that's an additional attack surface you're introducing. Okay, so to summarize, IDS and honeypots are reactive security tools to detect attacks. And for IDS, we have signature policy versus anomaly-based IDS that is often implemented in concert with firewalls or IPS. And you are able to perform classification according to the kind of sensors deployed and the level of distribution. The biggest challenges of IDS system is that you have huge amount of data to process, you have limited accuracy and a large number of false positives. And of course, there are aspects of privacy and IDS evasion techniques that I very briefly mentioned. And finally, honeypots as purely passive monitoring component, nearly no false positives.